My name is Kelsey Drew, and I'm going to show you how to use Geometer's Sketchpad to take a better look at parabolas. Parabolas are formed by a set of points that are equidistant from a point called the focus and a line called the directrix. One way to form a parabola is by using wax paper. First you take a piece of wax paper and you draw a line and a point on it like this. Then you fold it so that the point is on the line and make a nice firm crease like this. Then you keep doing that the full length of the line. Like so. Here's a few of them. Here's one that I have created already. As you can see, there is a nice form of a parabola there. This happens because the lines that we have creased are the tangent lines of the parabola. We can also use Geometer's Sketchpad to create the same formation of the parabola. To make the construction on Geometer's Sketchpad, first construct a segment, then construct a point that is not on the segment. We'll call this point A. Then construct a point on the line. We will call this point B. Connect these points with a segment. Construct the midpoint of the segment. Next, construct a perpendicular line through the point This is your crease line. Next, you want to select the crease line and select Trace Perpendicular Line. And we're going to animate point B. When I click on the Animate button, it moves B and the crease line. Crease line is once again the line of tangency to the parabola. As you can see, the parabola starts to form. With just a few alterations to this construction, we can prove the definition of a parabola. Here I have made the alterations to form the proof. I have constructed a perpendicular line at point B and also constructed the point P where the crease line and the perpendicular line intersect. I've also constructed the segment AP. Since M is a perpendicular line to AB, we have two right triangles, AMP and BMP. We can prove that these two triangles are congruent by the side angle side theorem. They share leg PM, and by construction, M is the midpoint of AB, so AM is congruent to MB. Since these two triangles are congruent, their corresponding parts are also congruent. AP is the hypotenuse of triangle AMP, and PB is the hypotenuse of triangle BMP. Since the two triangles are congruent, AP is equal to PB. This means that point P is on the parabola because it is equidistant to A, which is our focus, and B, which is on the line, which is our directrix, which proves the definition of a parabola. Now that we have this construction, we can play with it a little bit and see how the distance between A and the directrix changes the shape of the parabola. I have selected to trace point P and animate point B. So here's what the parabola would look like right now. Now I'm going to unselect trace P and move it a little bit. I'm going to move it farther away. I'm going to change the color of P and select trace and animate once again. You can see that moving the directrix away from the focus has made the parabola flatter. Now, if I untrace it and I move it closer, once again change the color, and select trace, animate, we see that by bringing the directrix closer to the focus, it makes the parabola skinnier. So now that we have this construction, there's a lot of things we can do with it, and I hope that you have fun playing with this construction and exploring more about parabolas.